Hello students, welcome to the lecture series on Introduction to Scilab Software, and this is video part 16 and we are solving question set 14. Now the first question is find eigenvalues and the characteristic polynomial for the given matrices. So the first matrix is, let us take the first matrix as A, which is equal to 3, 8, 8, 3. So this is the matrix. The command for finding the eigenvalue is SPEC in the bracket A. So we have the two eigenvalues -5 and 11 respectively. Now there is no particular command for finding the characteristic polynomial, but as we know that the eigenvalues are roots to the polynomial, which is we are going to call the characteristic polynomial. And we know that if the roots are known, we can declare the polynomial by using the command poly, and in the bracket let us write the roots. The roots are -5, 11, which are the eigenvalues, and therefore whatever the polynomial is generated will be the characteristic polynomial for the given matrix A. So P is equal to poly, -5, 11 are the eigenvalues and X is the coefficient. So this is the polynomial, which is the characteristic polynomial. Let us do it for the second one, which is B is equal to 3 minus 4, 1 minus 1, then spec B, the capital B. These are two roots, and for finding the polynomial we can write P is equal to poly in the round bracket. We are going to write the square bracket. We are going to write the roots. The roots are 1 plus I. We have the repeated roots 1 plus %I and 1 plus %I one more time, and then the quotes में X. So we get this is the polynomial of degree 2, which is the characteristic polynomial for the given matrix B. Now the next is declare the following matrices and also find the eigenvalues and eigenvectors. So let us declare the matrix A first. 10, -9, and then 4, 2. So as you know that command for finding the eigenvalues is spec A, but we want the eigenvector also. So what we can do, we can write in the bracket evac for eigenvectors, and we can use the variable eval for the eigenvalues, and then we are going to give the command, the same command, spec A. So here we got two columns as evac, column 1 and column 2, and a matrix of order 2 by 2 in which we have the off diagonal entries 0, and on diagonal we have the eigenvalues. So for the first eigenvalue, the corresponding eigenvector is there in the column 1. For the second eigenvalue, the eigenvector is there in the column number 2. So this way we can find the eigenvectors and eigenvalues. Let us do it for the second question, which is matrix B. It is 2 minus 3, 4 minus 5. So B is matrix. Now we can find spec B just to have idea about the eigenvalues. -1 plus I, 0I, and -2 plus 0I. So -1 and -2 are the two eigenvalues. So let us find the eigenvectors and eigenvalues. So we can write evac, eval, and spec B. The name of the matrix is B. So we have this eigenvalues on the diagonal entries of the matrix eval, and the corresponding eigenvectors are the column 1 and the column 2 of the matrix evac. Let us do the C question. C is a matrix of order 4 by 4. So we are going to have 4 eigenvalues. Then we have 4, 6, 1, minus 1. Then we have 0, 0, 1, 0. Then 2, 3, 6, 4. So this is my matrix C. So first of all, let us have the idea about the spec C. Okay, these are the 4 eigenvalues. Now for finding the eigenvectors, again we can write spec C. So we have 4 columns to the matrix eval and 4 columns to the matrix evac. You can see evac eval column 1 to column 4, and in eval also column 1 to column 4. So the corresponding eigenvector to the eigenvalue will be there in the respective column. Last question. D is equal to 2 by 3 minus 9, 6, 3, then 4, 6, 3, 8, 1, 0, 1, 0. Then E plus 1. For E plus 1 we are going to use %E plus 1. And then 5 minus 1, 4. So this is the matrix. Let us have idea by giving this command spec D. The name of the matrix is D, spec D, and evac eval spec D, this command. So this will give me all my eigenvalues and my eigenvectors. So how many columns do I have? In the evac, column 1, 2, column 3 to 4, and in the eval we have again 4 columns and 4 diagonal entries, which are nothing but the eigenvalues of the given matrix. So let us see the next question, which is declare the matrix A given below and find eigenvalues and eigenvectors. Also check whether A is diagonalizable, or compute P inverse AP. Now here we have to check whether the given matrix A is diagonalizable or not, or we have to compute the matrix P. Let us continue in the next lecture. The diagonalizable matrix, how we are going to check this. Till then, thank you so much.